So as a review, there are 4 ways of representing a function. We have a table, which would be your set of ordered pairs, a mapping, an equation, or a graph. Now, when something is a function, instead of writing y for my variable, a lot of times I'll write f of x. F for means, hey, this is my function, and my independent variable is x. It's just a different name. It doesn't do anything different. We have a chemistry teacher here at the high school named Mr. Nelson. He's actually a doctor. The fact that you call him Mr. Nelson, or if you call him Dr. Nelson, it's the same person. And we don't do anything mathematical with that. It's just the name. So we take a look at example 8 here. Here I have something in function notation. I have f of x equals negative 4x plus 7. I want to find each value. Now what we're going to do is I'm going to replace my input. Since it says f of 2, that tells me, oh, my independent variable x, that equals 2. So I'm going to replace x with 2. So I'm going to say, oh, f of 2 equals, instead of writing x, I'm going to write 2. Say negative 4 times 2 plus 7. Well, negative 4 times 2 is negative 8 plus 7. Well, that's negative 1. So f of 2 equals negative 1. Now, in example 9, it's similar. It's just a little bit more complex. I'm going to find f of negative 3. Whoops, I didn't mean to put my pen there. I'm going to find f of negative 3. Then I'm going to add 1. So first off, f of negative 3 is going to be negative 4 times negative 3 plus 7. But then I'm going to put plus 1 on the end. So instead of saying f of x plus 1, I'm saying negative 4 times negative 3 plus 7. That's my f of negative 3. Then I'm going to add 1. Well, now, order of operations is multiply first. So negative 4 times negative 3 is negative 12 plus 7 plus 1. It's not negative, though, is it? Messed up there. It's positive 12. A negative times a negative is a positive 12. Sorry about that. And then 12 plus 7 plus 1, well, that's 20. So my answer is 20. So that's f of negative 3 plus 1. Now, if your variable occurs more than once, like in example 10, the only thing that's different is we replace it more than once. So on my next example, I've got this function h of t equals negative 2t squared plus 68t plus 2. So every time I see t, that's my variable. So in example 10, I'm going to find h of 4. I'm going to replace t with 4. So in other words, h of 4 equals negative 2 times 4 squared plus 68 times 4 plus 2. Now, order of operations, I'm going to find the exponent first. I'm going to say negative 2 times 16 plus 68 times 4. And I'll add 2 on the end. Well, negative 2 times 16, that's negative 32. 68 times 4. Let me see. 68 times 2 is 176, so I double that again, and I get 272. I'll go plus 2. Then just work my way across. Negative 32 plus 272 would be 240. Plus 2 gives me 242. So in other words, h of 4 equals 242. Now in example 4, that one looks a little bit different, doesn't it? So we're going to start here, and it's kind of confusing because we're finding h of g. What the heck does that mean? Well, that means instead of writing t, I'm going to write g. So first I'm going to find h of g. I'm going to work myself from the inside out. So first off, we find h of g. Now finding h of g should be simple, but for some reason, a lot of people find it confusing. Instead of writing t, I'm going to write g. So I'm going to say, oh, negative 2 times g squared plus 68 times g plus 2. And there's nothing wrong with putting the g in parentheses, by the way. Now I'm going to multiply that answer by 2. So what I'm going to do is I'm going to use my distributive property. So I'm going to say, oh, 2 times h of g. That doesn't mean I'm going to replace g with 2. It means I'm going to multiply the whole equation by 2. So I'm going to say 2 times negative 2g squared plus 68g plus 2. Well, now I'm going to distribute my 2. So I get negative 4g squared. 68 times 2, we already said 68 times 2 is 136, so 136g. And then 2 times 2 is 4. So my answer then, if I write in function notation, is 2 times h of g. That equals to negative 4g squared plus 36g plus 4. And there is function notation.